Hi everyone, today we are here to present about the Turing machine. I'm Kabilashika and my index number is 216061B. I have done introduction and conclusion part in this assignment.
Hello everyone, good day to all. I'm Janani Halvala. My index number is 216042N. I contributed to the history of the Turing machine section of the report.
Hi everyone, I'm Warren. My index number is 216147P and I've done with Turing machine models and parts.
Hello everyone, I am Vyaza, 216111C. I have done how Turing machine works part in this presentation.
Hi everyone, I'm Pahan, 216094A. I have done the purpose and features of the presentation.
Hi everyone, I'm Prabhashi, 216063E. I've done the advantages and disadvantages part of this presentation.
Hi everyone, I'm Chamik Misharan, 216080D. I have done compare the Turing machine and the real machine in presentation.
Introduction. An abstract machine is referred to as a Turing machine. This device was created to provide a formal and operational explanation of the invention of discrete domain computability. Turing provided a superb example of how a machine might compute anything that could be computed through human computer by using a predetermined technique. It is made up of a finite program, known as the finite control, that can manipulate a tape, which is the list of cells that is a linear, using just a single access point, known as the head. Right and the left are the two directions of the tape. Any one of a finite number of states is possible for the finite control. Any process that can be computed by a machine is claimed by Turing. The Turing machine concept has established itself as being important to the advancement of data processing science during the past few decades. The machine runs on unlimited memory tape that is separated into separate cells. Each of these cells can retain and only one symbol chosen from the limited range of symbols known as the alphabet of the machine. A central process unit that restricts all computer-based manipulation of data is commonly represented as a Turing machine, with a standard machine having sequential memory to store data. It's an automated device that can list any subset of acceptable alphabetic strings. These subsets are components of an enumerable set that can be repeated. The endless tape on the Turing machine can be used for the writing and reading function. Turing machine that can imitate any further Turing machine known as a universal purpose Turing machine. Turing machine precisely define an algorithm or mathematical procedure and contain the informal notion, efficient, mathematical and logical method. Let me hand over to Ms. Janani.
Thank you, Kabilashika. So what is this Turing machine? A mathematical representation of a hypothetical computer device that may employ a predetermined set of rules to determine a result from a set of input variables. Now let's see who is the inventor of this Turing machine. The Turing machine invented by the Alan Matheson Turing. In 1936, Turing created this concept for a mathematical machine. Now let's talk about the inventor a little bit. He's an English mathematician, a computer scientist and a philosopher, born on the 7th of June in 1912, who played a significant role in the creation of the first computer by developing the idea of a theoretical computing machine. The device was an idea rather than a physical object, but its fundamental idea helped pave the way for the creation of digital computers later in the 20th century. Thank you, and over to you, Warren.
Thank you, Janani. Okay, now we can see the model and types of Turing machine. According to the notes, there are 7 types of Turing machine. You can see multiple track, two-way infinity tape, multi-tape, multi-tape, multi-head, and multi-dimension, and multi-head, and non-deterministic Turing machine. Let's have a closer look. First one is multiple track Turing machine. Which means the K track, the Turing machine has the K tracks. K track means it's greater than 0, and also one RNW head the reads and write each track individually. The K track, a signal track, can imitate the Turing machine or Turing device. Next one is two-way infinity tape Turing machine, which means two-way infinity tape Turing machine of infinity tape. Turing machines are unlimited in both and left-right direction. One-way infinity Turing machine are capable to simulating two-way infinity tape Turing machine. This is a standard Turing machine, which means two-way infinity Turing machine. Third one is multi-tape Turing machine. It's operated by a single head and has several tapes. Although the multiple tape Turing machine and the K-track Turing machine are distant, but they both have the same expressive power. Also, single tape Turing machine are capable to simulating a multi-tape Turing machine. Fourth one is multi-tape, multi-head Turing machine. The multi-tape Turing machine features numerous heads and tapes. Also, a distinct head controls each tape. And multi-tape atypical Turing machine can mimic a multi-head Turing machine. Next one is multi-dimensional tape Turing machine. It has a multi-dimensional tape with the head. We can move left, right, up or down. And also tape with many dimension, one-dimensional Turing machine can simulate the Turing machine. Multi-head Turing machine. It with multiple heads may read the symbols on a single tape using 2 or more leads. In a single motion, each head independent or moves right after sensing a scannable symbol. Its single head Turing machine is capable to simulating a multi-head Turing machine. And the final one is non-deterministic Turing machine, which means one-way infinity tape exit in non-determinate Turing machine. For a given an input symbol, there's at least one possible move. A finite number of moves are possible, and for a particular input string, each possible move has a number of possible paths. And also, it's equivalent to deterministic Turing machine to have a non-deterministic Turing machine, deterministic Turing machine. Thank you, and over to Riaza.
Thank you, Warren. I'm going to talk about how Turing machine works. An indefinitely long tape that has been divided into cells makes up a Turing machine. A1, A0, or an empty space are the only possible values for each cell. A head that can move left or right and can read the symbols written in the cells is located above one cell of the tape. When the tape reads any particular symbol, it decides what to do depending on the set of transition functions associated with the machine. The way of Turing machine uses the structure. First, the input is written on the tape. After that, the device begins by reading the first symbol and then substitutes a new symbol for it in accordance with a set of criteria. After that, the machine repeatedly performs this read, write, move cycle until instructed to stop. Finally, the output of the computation is the string that is entered on the tape at the conclusion of all of it. Now, I will hand over to Pahan.
Thank you, Riasa. Now we'll talk about the purpose of Turing machine. So firstly, the Turing machine has been employed as a language generator since it includes numerous cassettes, one of which is empty at start and gradually filled with language terms. So it is deciding the formal language. Then it also has been used as a solving mathematical functions. Next, we'll move to the features of Turing machine. So the tape's input. Firstly, we can talk about the tape's inputs must contain a limited number of symbols where the calculation begins. So next, the length of the tape is infinite. And the read-write head has programmability options. The Turing machine is capable of 6 fundamental operations: reading, writing, left and right movements, state change, and halt. Next, it can compute anything that a contemporary computer can compute. It is made up of an input and output alphabet as well as a unique symbol known as byte. It has an external memory that can record an arbitrary lengthy series of input. It has an infinite memory capacity. Over to you, Prabhash.
Thank you, Pahan. I'm going to talk about the advantages and the disadvantages of the Turing machines. So advantages are great computable capability and a language is recognizable. So Turing machine is one of several possible simplified models of the idea of a computer. They are simple to describe, simple to use, and suitable for demonstrating that some things are challenging or impractical. Turing machines have the advantages of unlimited memory, even though they are similar to finite state machines. They can actually solve problems that no finite computers can because they have unbounded memory in contrast to real computers. Disadvantages are computational complexity theory. The strength of a particular arrangement are not well modeled by Turing machines. Modern computers with stored programs, for instance, are examples of a more specialized type of abstract machine known as random access stored program. Then another limitation is they do not concurrency well. So over to you, Cham.
Thank you, Prabhashi. Considering the similarities between the Turing machine and the real machine, the first one is a Turing machine can perform every calculation that a real computer can. A Turing machine, for instance, can imitate any kind of substitute found on programming languages, including operation and any of the recognized parameters passing techniques. The next similarity is like a Turing machine, a real machine can add additional disk or other storage media as needed to increase its storage capacity. Considering the similarities between the Turing machine and the real machine. The first one is a Turing machine can work with a limited amount of data and a real machine can work with an infinite amount of data. That is, a Turing machine can only work with a limited amount of data given a limited amount of time. The next one is when compared descriptions using Turing machines, descriptions of real machine programs using similarly abstract models are frequently significant more complex. For instance, while the comparable determiners limited on physical machine contains of state, a Turing machine expressing an algorithm may only have a few hundred. The next one is the formulation of algorithm is made simpler by Turing machines. Due to the availability of specific data types and the absence of unexpected situations, algorithms running in Turing abstract machine are typically more general than those running on real computers. Thank you, and over to Kabalashika.
Thank you, Shamika. So far, we have discussed about the introduction to Turing machine, history, models and types, how Turing machine works, purpose of a Turing machine, features, advantages and disadvantages, comparing the Turing machine to the real machine. So as a conclusion, a Turing machine or a personal computer can perform every logical calculable functions. It is a digital device that is both powerful enough to cover every discrete object that can be computed logically, and it is simply enough to be the subject to theoretical study. As if that weren't enough, many significant complexity classes in the theory of computation can be simply described by an adequately limited Turing machine. Turing machine has two functions, such as total computable and partial computable. Turing machine usually has binary types of symbols. Regarding the Turing machine setup, there are two significant things to note. The first related to the machine's definition, especially that is tape infinite. The second is about how a function will be Turing computable, which is the definition of Turing computable. Anytime throughout the computation of T, its definition is determined by the tape's data word, reading head location, and internal machine status. Different types of problems and languages can be recognized and decided by Turing machine. Issues are described in languages. Thank you for the great opportunity. Have a great day.